Sorry.
No, they're not here
So-
with us.
To begin, life in its various forms continues on, continuous despite our human efforts to overcomplicate civilization and oversimplify nature. Yes, we do that all the time. We channelized that stream and it flooded. Why did that happen? You know, duh. The other thing is that we think the public wants simple answers. You know, politicians definitely want simple answers, but people, no, we don't need simple answers, and there's no simple answers to some of these questions. But do they really? We don't need the dumb science down to get people to pay attention. My favorite line when I was working is one day I would be talking to third graders about biodiversity, and the next day I might be talking to state legislators about biodiversity. And guess what? I used the same material for both. Actually, sometimes I had to dumb down the third grade stuff. Can you put that on 2 sentences for me? Okay. So, to begin, the Earth is unique. And what sets the Earth apart from all other planets in our solar system, from all other planets in our galaxy, from all other planets in the universe, as far as we can be able to tell, people would say it's water. No, it's not water. It's something else. And what is it? It's life, right? Life. In 1973, a new term was coined called biodiversity. And this one was also called, I don't know if I like it or not, but it's called the Goldilocks planet. In other words, we're not too hot, we're not too cold, we're not too far from the sun, we're not too close. It's perfect for life to develop, and life has developed in enormous amounts. So what is it? Well, the scientist said biodiversity, that's really annoying. It's the number of plants, animals, and habitats on Earth, and that's damning with faint praise, right? That's what a scientist would say. But it's the plants, it's the birds, it's the habitats. Anybody ever seen an expletia forest before? You know, the Earth is full of unique places and unique habitats. The other thing that we've come to know is that biodiversity in cloud forest, with its sword-billed hummingbirds, its orchids, the African savanna with its lions, with its zebras, we call those charismatic megafauna. And the reason we do that is because in today's world, US citizens equate biodiversity with existing somewhere else, right? Tropical rainforests, coral reefs, African savannas, etc. In short, it's someone else's problem. Those damn Brazilians are burning down the rainforest. Look at their history of Illinois in 1840 to 1860. We did exactly the same thing. The difference is, under our forest, the best soil on Earth, and under our prairie, under the rainforest is the worst soil on Earth, right? So, we need to get over that. So it's time to have an intelligent conversation about biodiversity. And that's not an easy thing to do. We need to look at habitats, we need to look at organisms, we need to look at insects. You're Audubon, so you focus on birds, that's great. I'm an entomologist, so I focus on insects. And a great diversity of insects. So, insects, what are we going to talk about? Well, here's a great spangled fritillary on colic root. Anybody ever seen colic root? You guys have colic root up here? Yeah?
Yeah.
It's a great butterfly plant. You can't grow it in your garden, but it's a great butterfly plant. Anybody ever seen cottonwood borers?
Yes.
Yeah, got tons of cottonwood, right? It's a place in southern Illinois where the Ohio and the Mississippi come together, called Fort Defiance State Park, where Lewis and Clark camped in 1803. You go there in July, cottonwood borers, right? Dragonflies, like this Halloween pennant. We have 67 to 68 species of dragonflies in Illinois. So, the bulk of all life, whether a biomass or numerical abundance or numbers of species, is comprised of invertebrates such as insects, spiders, worms, and so on. I'm gonna see if I can make that a little bit smaller. No,
Can we
this is why,
hit okay on your screen?
You gotta press the blue OK button.
Yeah,
yeah, okay, you do it without breaking it.
yeah, that's what
I can do it. You want me to do it right?
okay,
All right,
I think
I can't find the mouse.
it's a touch.
probably have to get out of the talk
Yeah,
first.
I bet we'll have to get out of the talk. I mean, that
Here,
is-
hit escape. Now try.
No, yes,
You're on it.
yeah, but it's not doing.
It won't do it, okay.
So
No.
unescaped.
Now you got it. Okay, sorry about that, folks.
But you can't get out of it.
Is this the third grade version?
Yes. We can't get out. What are you trying to do?
I'm trying to get my talk back. I can't see it now, see?
Yeah, where are you going?
There you are.
Okay. Okay, well, we're gonna have to start over.
That display is actually okay because we can read it.
I hit the okay button, I didn't do anything.
I think you might be able to just leave it.
If you go into presentation mode on your slideshow.
Yeah.
See that, let me move this over.
Here, can you go up here to, where's presentation?
Play, it's under this black thing.
Oh, here,
What?
It looks like a man X.
Play?
yeah, hit that, see what it does. Or are we frozen?
We've frozen it,
We've
okay.
Frozen it now. Oh,
All right, here we go again.
but now what about the zoomers?
There you go. Try clicking OK again.
I don't think it's gonna work.
Nope.
Oh.
Okay, I'm gonna shut it down, start over. Am I good?
Yeah, see, it's still there, but
Okay.
that's okay.
All right. Invertebrates, worms, and so on. I know what this is. You've seen the pits in the sand. That's the adult ant lion. Baby stink bugs. You know, baby stink bugs always come in multiples of 7. It's another one of those mysteries we don't really know. Prairie cicadas, absolutely not prairie cicadas, periodical cicadas. We had a big outbreak last year. It's been all over the news. Most of it is, what am I going to get rid of it? Nothing. You enjoy them. If you look at a textbook on entomology, this is the biodiversity of the earth. I mean, on biodiversity, this is the biodiversity. There are the mammals, the little sliver there. They're the insects and their relatives. So when someone tells me insects aren't important, yeah, they sort of are. About 2 million described species on Earth. Estimates are between 5 and 50 million species that we haven't described. 50 is probably high, probably closer to 10 million species. So something has happened in the last 50 years, and I've seen it happen. I'm that old. In the last 50 years, we have reduced the abundance of wildlife on Earth dramatically. Many species that were once common are now scarce. Much attention focused on the decline of large charismatic animals, bison, spotted owls, elephants, lions. But recent evidence suggests that abundance of insects may have fallen by 50% since 1970. Okay, that's not cockroaches in your house. That's insect life. This is troubling. Perhaps more frightening, most of us have not noticed that anything has changed, right? Unless you're looking at it, we may notice there are fewer bugs that you lighted on your porch light. You drive from Chicago to Cairo, Illinois on I-57, no bug splatters, right? So that's some evidence that things aren't as they should be. Documenting this scientifically with scientific papers is extremely difficult. It's multi-year studies. It's darn difficult. Scientists don't get tenure doing this kind of research, so it doesn't get done. But in recent years, there's been scientific publications on insect decline, most of it from Europe, Germany, from the UK, not many from the United States, because most of our grand proponents of biodiversity are old or dead, right? Not me, but it might be better to look at some of the recent books, and there are some awesome books out on the insect decline. This one is the best, The Insect Crisis. It's a brilliantly written, very readable book, very poignant. This one is also very good. This gentleman is English, and he has a solution to all the world's problems, and it's perfect. No one will ever do it, but it's perfect, right? So we do know what needs to be done. So, Vanishing Edens, the unseen life of our Goldilocks planet. Okay. As E.O. Wilson said, this is the assembly of life that took 1 billion years to evolve. It has eaten the storms, folded them into its genes, and created the world that created us. It holds the world steady. Since I was a graduate student in the 1970s, molecular biology has taken off. I mean, when I took genetics in 1970, it was Mendelian genetics. I mean, that's like kindergarten stuff now, right? But there's a big difference between a molecular geneticist and a systematist who deals with real organisms, and there's a gulf there. But they're beginning to come together and determine what and how important biodiversity really is. The other thing is we have a responsibility. We're supposedly intelligent creatures. So through our intelligence, we have become the protectors of the continuing survival of life on Earth. We didn't ask for this role, right? But we cannot decline it. It may be that we are not up to it, but we must set about it. We keep setting about it. We set about it in the 60s with Silent Spring. We set about it in the 70s with DDT. And we've kind of forgotten about it until now. So it's time to reacquaint ourselves with biodiversity. All right. How do you study insects? Here's myself and a colleague in northwest Ecuador on the border with Colombia. We wanted to see what insects were there. We were only there for 2 days. So what do? You put up a light, put a sheet up, and fortunately they had a generator. There was no electricity here. And then you see what comes. Oh boy. It's amazing what comes. You know, Rothschildian moths, huge things you just dream about of an entomologist as a kid. We were recently in Ecuador on the top of Trusmati Mountain.
Borneo.
They had 10 black lights set up every night. And we went out, we spent every evening and every early morning looking at what came to the lights. And it was absolutely amazing. If you guys don't believe in evolution, here's an example for you. Look at this moth closely. What do you see? I see a bird dropping, right? Look at the wings. What do you see? You see a fly. Flies feeding on the bird dropping. Now that is mimicry taken to the nth degree. And somebody once asked me if evolution has a sense of humor. I don't know, but it sure has some precision associated with it. We saw giant beetles like this Chalicosoma atlas beetle. The biodiversity that entomologists dream about as kids. But what about, we don't live in Borneo, Illinois. What about the insect life of Illinois? We have some fascinating things that go on. You go on at night and just walk around and with a little light. You might see this. These are tree crickets. This is called nuptial feeding. The male, this is the male, this is the female. He has deposited a little nuptial gift for her. So she climbs on his back, she kind of sniffs around here, and then she'll climb down, eat this, and while he's eating it, he mates with her. Okay? How did they get together? The male has this beautiful melodic call, right? If you saw this in a forest in Illinois, you'd go, well, that's just a lump, right? That's a slug caterpillar. Head is here, tail, toxic spines, makes this little brown moth, but perfectly camouflaged. Illinois has cute insects. There's no cuter insect than the larva of the spicebush swallowtail. Feeds on sassafras and spicebush. Mimics a rough green snake. Rolls itself up in a leaf, sticks its prothorax out, looks like a snake, and feeds at night. So, we like pretty things, right? We like pretty things. And Aldo Leopold kind of started this in the publish of Marshland Elegy. He said, our ability to perceive quality in nature begins as an art with the pretty, right? It expands through successive stages of the beautiful to values as yet uncaptured by language. we want to see something that attracts our attention, and what attracts our attention is attractiveness, prettiness, right? So. In Illinois, we have basically trashed the whole landscape, so restoration and conservation is very vitally important in Illinois. And Illinois, I've noticed, I've been doing this for a long time, we tend to create Eden-esque landscapes with a restoration effort. Absolutely, we want them to be pretty, right? Yes, we burn, we do this, we do that, we cut brush, we want them to be pretty. And I love every one of them. This is a Green River Conservation Area. This is Illinois Beach State Park, 20 years ago. This is Mississippi Palisades State Park. They're beautiful places. These are the sandstone glades in southern Illinois, Shawnee. Absolutely spectacular habitats. But there's an issue that has arisen over the last 30 to 40 years. And when we see a habitat, what is our perception of it and what questions come to mind, right? We have to answer these questions because we have no baseline. There were no scientists here in 1750 documenting the landscape. So we have to ask questions. How can we preserve this landscape? We see it right here. It's beautiful. We want to keep it just like that. Do we want to keep it just like this in perpetuity? With prairies? Yeah, we do. How can we restore this landscape if it's less than we think it should be? Okay. Where does it currently fit in on the successional scale? And what should it look like? Those of you that took ecology in college and high school, you learned about succession, right? The normal progression of plants to climax communities. Changing climate changes climax communities. So where does this system fit in? I once had a money manager for DNR. I was trying to get money from him to do work on prairies, and he says, well, just buy some land, don't plant it with corn, and the prairie will come back. No, it won't come back, right? It's not there anymore. So we have to start from scratch. And do we know, this is an important question, do we know what was here to begin with? Insect-wise? No. Plant-wise? Yeah, maybe. Right? What's missing that we can add back? What should be removed? Exotic species, things that we think don't belong there. In short, what is our baseline for conservation efforts? And guess who's been in charge of this for all the years of Illinois? Botanists, right? Botanists. I know because I work with all of them, right? Botanists. We restore the lands. They say, well, if you restore the plants, everything else will be fine. Well, maybe, maybe not. So that's the introduction. Let's look at habitat complexity. Each species, as E.O. Wilson said, is an eons old magic well of genetic information. One of the least favorite things people ask me is, what good is that insect? What good are you? You know, it's exactly. I could ask you, there's a lot of you. What good is one of you, right? So I've been called a whimsical cynic, which is perfectly fine. But one of my colleagues at Purdue said, the more complex the network is, the more complex pattern of interconnections, the more resilient it will be. Right? How many have all your money in one little place? Well, no, you're supposed to diversify and put it all over. The same thing applies to ecosystems. So the question is habitat complexity. This is a limestone glade in the Shawnee National Forest. With regard to insects and arthropods, 1,000 distant memories, which we don't have, right? So how do we talk about complexity? That's a really, really difficult thing to talk about. So this is a coal forest in Pine Hills in southern Illinois. This is celandine poppy. You know, there's almost as many species of plants in the Pine Hills as there are in the Great Smoky Mountains. So the wonderful complex habitat. So let's portray it this way, so we can understand, sort of, right? So you pull different levers and you set in motion a cascade of consequences. If you spin this one, this thing spins up here, but you had no idea why that was spinning and all the interactions. So that's kind of the way our conservation efforts have gone. If everybody's ever taken an ecology class and seen something like this, a food web, they say, oh man, that's amazingly complex. That's ridiculously simple compared to the real world. Here, fungus. There are at least 2,000 species of fungus in Illinois, fungi. Small insects. 10,000? Who knows? No one has ever completed an intact functioning food web. It's just simply too much to do. So that's a nice way to portray it. In an ecosystem, everything is connected by a net of interactions. Every time you lose a species, you're cutting some of those links in the network. The more links you cut in the network, the less the internet there is left until eventually it doesn't work anymore. Absolutely. Anybody remember Paul Ehrlich in the 70s? He was talking about biodiversity, and he says, imagine you're getting on a jumbo jet, and there's this little man sitting on the wing popping out rivets. And so the guy says, why are you popping out rivets? He says, oh, you don't need all those rivets. You don't until the wing falls off, right? So would you get on that plane? Yeah, who knows? There's another way to look at complexity. This is a pin diagram. This is a forest. And over the years, scientists, ecologists, we've tried to get a handle on this complexity. We've done lots of things. We do ecosystem level interactions between organisms, like that food web that we showed you. We do gills, like all the insects, say that suck plant sap from a tree, all the carnivores that feed on, all the animals of different types, those are gills. Food chains, food webs, we've tried that too. Tritrophic interactions. In the 80s, tritrophic interactions was a big deal. What is documenting what, say, a plant is eaten by an insect, which is attacked by what? That's a tritrophic interaction. Quadritrophic interaction, all those things, if you put enough of those together, you get the resemblance of a food web. I'm sure you've all heard of FQI, Floristic Quality Index. For all the plants in the Chicago region, all have numbers associated with them, right? Floristic Quality Index. Soon I developed one called the BQI, the Butterfly Quotient or Quality Index. Okay, and et cetera, et cetera, et cetera. There are tons of them. So you take as many of those as you can stomach. It takes a supercomputer, and you begin to tease out the complexity. Still complex, but it's a little bit less so. There are choke points where we can determine, make it in relatively informed decisions. So, given that, the highway to understanding an ecosystem it's confusing. Absolutely, it's confusing. Whenever I give this talk, they say, oh, we can't do any of that stuff. It's too confusing. So we do something simple. We drive a pin nail with a sledgehammer, right? So if we want to end up with something intact with all its organisms, it turns out to be inspired guesswork. Experience, right? Experience. You do this, you get this. And based on your knowledge and the scientific information in the background and your knowledge base, you may or may not get it right. So, to continue, my spouse, Sue Post, is a wordsmith. And no word is more evocative to her than Serengeti. If I say Serengeti, you have this vision of this great plains and thousands of wildebeest, chased by cheetahs and lions and so forth. It's very evocative. I'm going to tell you, Illinois is an arthropod Serengeti, right? We've been looking at it, Sue and I've been looking at it for a very, very, very long time. There are hundreds of species of grasshoppers, 77 species of butterflies, which you can regularly find. Grasshoppers live only on rock ledges in southern Illinois. And they're lichen grasshoppers, very specific. And the insect that has been rapidly disappearing in the last few years, surfeit flies. Why? Who knows? But as E.L. Wilson said, these are the little things that run the world. All right. Here's another way to look at complexity. Here's an ecosystem. That's what we think we know about the ecosystem, right? All those green things. But look, what do we have here? What are these? You're an astronomer, they're black holes, right? We don't know what's in a black hole, right? And believe it or not, in Illinois, most of those black holes in our knowledge are populated by arthropods, by insects, like this dance fly, like this plaster bee that lives soil dwelling. Those of you that don't have lawn services and have bare spots in your yard may have plaster bees in the springtime. And the other thing is, I often heard restoration ecologists say, well, we burn the forest or the landscape to get rid of all that duff so the plants can come up. Have you heard that? Many times. When you burn the duff, this is what you're getting rid of. Right? This is 1 square foot, 1 centimeter deep in the Shawnee National Forest. And I have no idea how many species are there. There's several different phyla. And all of them are arthropods, and they're all doing something, right? We don't know what they're doing. They're doing something. These insects nourish the soil, the 15-centimeter patina that cloaks the forest floor. So, when we manage things that we don't understand. The other thing is that Sue and I have been photographers our whole life. And what I like about a photograph is that they capture a moment that's gone forever, impossible to reproduce. There it is. I took it. There it is. And this elephant stag beetles. This is a male and female courting. These are tree cattle, Socoptera. Anybody ever seen a Socopteran? We did a biodiversity blitz or bio blitz at Allerton Park in southern Illinois. It's a forest. In 50 years of looking through insects, I'd seen Socoptera in the wild, bark lice, twice. We invited Dr. Edward Mockford from Illinois State University, who was the world authority on Socoptera. He took one of our technicians. He walked in the forest for an hour and he found 62 species. Right? Way to go, Ed. So, what I like about a photograph, right, it's an observation. So each observation is subject to interpretation. You can all look at that photo and interpret it differently. Mine alone, where science has failed to articulate any explanation. You'd be amazed how many times soon I take pictures of something. What are they doing? You know, I've never seen that before. The observation, however, is immutable. You can't deny what you see. Much like a colorful bird skin with dead cotton eyes lying in a museum cabinet, or a specimen quietly residing in a fragment of cloudy amber. Each awaits an inquiring mind to see what mysteries are held within. So, a sample, the wonders of Illinois insects, and there are lots of them. Soon I maintain a website. I've got business cards up here which has biodiversity from Illinois and biodiversity from the entire world. You're all welcome to use any of them. They're just up there. But it's an amazing thing to start documenting everything that you see. Right now, what this is? It's the watermelon. I know. My grandfather grew up in Southern, was a very frugal man, very frugal. If he wanted to buy a watermelon, he demanded to sample it first. So you would take his knife and he would cut a little square, pull it out, take a bite out of it, and if he liked it, he would buy it. If he didn't, he put the thing back. Right? Anybody ever do that up here? Must be a southern thing, right? So we're going to look at ecosystem interactions. We have to sample something. We have to do something. And sometimes it's easier to absorb a large canvas, for instance, the Shawnee National Forest or Illinois Beach State Park, by examining it one small detail at a time. And that's okay, because you learn things. So let's look at the Shawnee National Forest. The saga of the Ozark checker spot. You guys up here have the Baltimore checker spot butterfly, right? In the wetlands. He's on Turtlehead. In southern Illinois, there's a sibling species called the Ozark checker spot, which feeds on false foxglove. And it has some interesting characteristics. It's very local. It's very local, but doesn't fly around much. And if you look at the life cycle of a butterfly, this is from a third grade textbook. You see egg, larvae, pupa, caterpillar, chrysalis, adult. Pretty simple, right? A third grader can understand that. But to understand the complexity of it, it takes a little more doing. You have to deal with volcanism, the number of generations an insect has per year, the host plant specificity, what is it feeding on, and is it wide or oligophagous, monophagous, polyphagous? How does it spend the winter? Because we have winters, we have to worry about that. Insects in the tropics have to worry about wet and dry. Here, great variety of conditions. And habitat dependence. So you take those four things, you apply those to an organism, you run into a problem because we don't know that about most of the organisms, most of the insects. We have no idea about most of this stuff. But for butterflies in Illinois, we do. Oh, thanks. You're welcome. We did that. With this in mind, we wrote a field guide with as much information on butterflies. We didn't include skippers because people don't know those information about skippers. They know how to identify them, but that's not enough. So you take that information, and here's the Shawnee National Forest. Here's the Ozark checker spot. A little bit of complexity in this vast ecosystem. This is its habitat of barrens. In the Shawnee National Forest, it's hilly, rocky, and where these rocky outcrops come to the surface, you can see the rocks here. It's too rocky for trees. So the canopy is open, and the forest underneath is basically a prairie landscape. And these things can be about maybe the size of this room, a little bit. That one with all the coneflowers was a sandstone outcrop. This is the habitat of the Ozark checker spot. It's hot, dry, and open. Here's the Ozark checker spot, nectaring on purple milkweed. These are some of its colleagues. These are bright spangled fritillaries, but the Ozark checker spot is unique here Because it is one host plant.
False foxglove.
False foxglove, which is a partially parasitic plant on oak roots, okay? The other thing is, the Ozark checker spot has one generation per year, one. June, May, June. So the female, she'll emerge, fly around in June. And she lays, when she's done feeding like this, she'll lay eggs in a cluster. And the larvae develop, cluster together, make this web on, you see at the base of their host plant. And when they get to the third instar, they stop feeding. And guess what? They fold up, the leaf dries, folds up around them, and they fall down to the soil. Right? They spend the winter that way. And then in now, April and May, the larvae wake up, they start feeding, and they can feed on more than one plant now. And they pupate, and within 12 days, you get Ozark checker spots. Okay. That's a pretty unique ecosystem. And you noticed in that pin diagram, we had a choke point, right? A choke point, but one dot. Where was it? Where do you think the weak link in this ecosystem is? It's just humans weren't here. It doesn't have one. But that is the weak link, because the policy of the Shawnee National Forest is to prescribe burns to maintain these glades the way they should look. You've got prairie vegetation under it and so forth, right? We've been looking at this place for many, many, many years. It's one of Sue's notebooks. This is what the glade looks like after the Forest Service is finished with it. Okay, you see, there's the edge of the forest, there's the sandstone glade. This is the forest around it. Hundreds of acres, all burned. Okay, oh, we're managing for oak ecosystems. Get rid of the duff, let the plants bloom and come up, and we're happy. And guess what? The food plant of the Ozark checker spot loves fire. It flushes. There's false foxglove everywhere. Guess what's not there? Ozark checker spots. Why? Because they were a part of the duff layer as caterpillars and dry leaves, right? What happened to them? They succumbed to the fire. And in a few weeks, the butterfly weed comes up, and it's covered with butterflies. But it's covered with butterflies like great spangled fritillaries and big swallowtails, which are wide, free-ranging butterflies. And they come and the Forest Service said, "Oh look, we didn't do anything. The butterflies are all there." Well, that's kind of clumping everything in misinformation. Because butterflies are less flexible and restricted to a single reproductive cycle a year, are less likely to fare well. Butterflies therefore become the quintessential Goldilocks creatures. We can go to any glade in the Shawnee National Forest and tell how they managed it by what insects are there and what insects aren't there. Because there are other things. The spring ephemeral orange tip. Guess how it overwinters? As a pupa, about this far off the soil. The silvery checker spot overwinters as an egg. These things disappear with management. Okay? So which makes them ideal candidates for monitoring. Let's look at Illinois Beach State Park. I added this because I got an email from Brad. We went there today. We've been there several times. This is Illinois Beach State Park in the winter. We walked in this area over here. had been burned. I'm not sure why, but the dunes and so forth had been torched. This area had not been. And we were looking for two things. First of all, this Illinois beach, it's a dune swell and swell topography, a very complex ecosystem. We were looking for bearberry, which is a listed species in Illinois as far as endangered species. Grows only on the 4 dunes in Illinois Beach State Park. And guess what it has that feeds on it, and it feeds on nothing else. You guessed it, a little butterfly called the hoary elephant. This hoary elephant has 1 generation a year, 1 host plant, overwinters as a pupa. The bearberry never gets more than this high, right? And essentially, it's exactly the ecological equivalent of the Ozark checker spot. So you can put 2 and 2 together. What happens if you burn in such a habitat? You lose these. We actually saw 3 or 4 today on an area that they hadn't burned. So how do we measure that? Here's what the burned area of Illinois Beach looked like. Thanks, Brad, for the photographs. Normally, this should be surrounded with bearberry, but not so much. All right, what all this leads to is what we call damping butterfly sine waves. What does that mean? First of all, butterflies, like most insects, are cyclic. Up, down, up, down, up, down. They have good years and not so good years. This is what a damping butterfly sine wave looks like. And this is what the insects, most of the insects in Illinois are undergoing. This is just a theoretical, if you have a damping sine wave in your heart monitor, you're in the hospital, bye. When it gets to 0, you're dead. This is the monarch butterfly population in Mexico over the last 20 years. It's a damping butterfly sine wave, right? So it's true. We've recorded in central Illinois, Sand Ridge State Forest. This used to be one of the best butterfly places in this state. There are 42 butterflies, 7 different species on this one plant. It was an amazing place. That was 20 years ago. 10 years ago, we went back and it was, still pretty good. Now, it looks like this. The site manager for the area took it upon himself to manage for upland game. You know what upland game management is? Birds you can shoot. So he planted oats or something in there, but he also had western cheatgrass in there. And this is all western cheatgrass. And we don't even have milkweeds anymore. The whole thing has disappeared. So this, in 20 years, is the butterfly population in this area, Sand Ridge State Forest. It's no undulating sine wave, it plummeted, right? And then the gentleman retired, and in ancestral memory, the only one who remembers it's Sue and I, right? Maybe Jim Whiteman. So butterflies are the quintessential Goldilocks creatures that we can use to monitor. So we're going to go back to those 4 things. 8 years ago or so, we did a project. We came out of retirement, did a project for the Department of Natural Resources on developing a butterfly monitoring network for the state of Illinois. And we used these variables to assign each butterfly a number. Each one of these 0 was from 1 to 3. 1 being the less conservative, 3 being most conservative. If it was 1 generation a year, it was a 3. If it was multiple generations a year, it was a 1. If it overwintered in anything except an adult stage, it was a 3. If it didn't overwinter in Illinois and colonize every year, it was a 1. Okay, so when it was adult, it was a 2. And that information was gleaned from our information on butterflies. So, a perfect butterfly would be a 12. Guess what? A hoary elephant at
Illinois
It is.
Beach,
He was there.
where were we?
Illinois Beach.
Illinois Beach State Park is a 12. Okay? The Ozark checker spot is a 12, right? So that means it's a highly conserved, good indicator of habitat quality. How do we know? Well, we developed a couple of equations here. This is for the less mathematical, this is for the more mathematical, but it gives you a number which you can use year after year after year to monitor a site. You mentioned butterfly monitoring. Here's a good way to go about it. The bad news is the sampling technique is you walk through the habitat for a given amount of time. You identify every species you see on the wing without touching them. Okay? As you know about Heisenberg and uncertainty principle, if you start with a net and so forth, you disrupt. And soon I did that 3 times in 30 sites for 3 years in different habitats. And guess what? The pristine nature preserves that are managed and are beautiful are bereft of butterflies in Illinois. The mid-successional, early successional landscapes with trails through them and some disturbance had many more species in them. So it's telling us something about our habitat management. Okay. Those of you that are old enough, remember there are 8 million stories in the naked city. Remember that TV show? And these are only examples. There are 2 examples. I use butterflies. So let's continue. Let's look at a little more complex example. This is from the Shawnee National Forest. It's called the rock-loving crane fly. Nobody loves crane flies, right? It's big things that look like mosquitoes that come to your porch side at night. So it's called disturbances, rock ledges, crane flies, and wildflowers. Oh my. This is called a cuesta. This is in the Shawnee National Forest. This is where the bedrock comes to the surface. And this is north slope, south facing, south slope, north facing. So these 2 habitats are different from each other, right? But they are habitats and they maintain themselves, and they've maintained themselves since glacial times for 10,000, 20,000 years, probably even longer. This is Dactylolabus Montana. It has no common name. Rock-loving crane flies, good enough. And this ecosystem that it lives in is called meticulous. That's the word for you. This is where water seeps over bare rock slowly. That's a meticulous habitat. Okay? I don't know if you have those up here or not. You might, I don't know. This is the meticulous habitat. See the water seeping over the rock? And it usually only happens in the springtime, so it's an ephemeral habitat. And we know this has been going on for a very long time because these little trickles of water from the forest up here, they've worn channels in the rock, right? And they're dark, they're wet, and they have brown algae in them, and red algae and green algae. And if you step on one, you're going to bust your butt because they're really slick, right? This is the habitat needed by this crane fly. Here, you can see it here. This is an early spring. These are all over the place. Anytime you find a sandstone outcrop in southern Illinois that has a slope to it, this ecosystem exists. In the summertime, when it dries up, you see there's not much soil deposition because it's coming out of a forest. The water's clean. You end up things with moss and a few lichens, but not much else grows there. And this was the last scientific paper I ever published before I retired. It was in the Kansas Journal of Entomology. And in the 1970s, Sue and I and a bunch of other students went there. And you can see this. This is a mass of rock-living crane flies. You say, so what? These are all males. Virgin males. Males that have not had a female yet. A female will walk by. And she sees this mass of crane flies, and we've seen it as big as volleyballs. Usually it's about the size of a softball. Now, if you have 8 or 10 together, you're happy. And guess what? The males go crazy. And out walks this unlikely pair. Here's the female, she's bigger. Here's the male. Now, whether he chose her or she chose him, we don't know. But he is protecting her with his legs. He made a cage over her. He mates with her. Walks her over to one of these dripways, and she lays eggs while he's protecting her. Right? Here. This male didn't get the memo. He comes. And it's very amusing to watch. This male is fighting off the other male while the female is down here laying eggs. Trying to, because crane flies have a thing called sperm precedent, which means the last one to mate is the one who gets to fertilize the eggs. So it's very amusing to watch. It used to be very, very common. These are the little larvae, crane fly larvae. They're predators. They either, we don't know if they crawl up the dripway into the forest or down the dripway into the stream. Something we didn't investigate, but they make the one generation a year, and they make crane flies. All right, something has happened in this Shawnee in the last 40 years. You ever heard the term multi-use trail? Yeah, I hate that term. Multi-use trail, which means anybody should be allowed on a trail. 4-wheel vehicles, horses, hikers, you name it, right? The other thing that Shawnee's doing is their forest management, where they're removing the understory. They're even doing things like clear cutting, getting rid of the big oaks and so forth. All of this leads to one thing, we know it. In California, what happens when the vegetation burns and it rains? Mud, right? Mud. The trails begin to look like this. And if this happens uphill from one of these cuestas, these sandstone ledges, these meticulous landscapes, they look like this in a couple of years. They're beautiful. This is wild false garlic, bluets,
What's
all these
wrong?
native plants that couldn't get a hold there before are there blooming because all the disturbance has silted in the dripways. But I showed this to Tony and he said, well, that's just fantastic. I said, it's not fantastic because it's wrong. You created this, right? You created this and the crane flies are not here anymore. Same thing happened. This is Jackson Hollow Barrens. This is the Barrens. They fixed the road. This is a gravel road. They put in a new culvert. And guess on the other side of the road, they had burned this season after a rainstorm. These are the dripways. They're all full of silt. There are no crane flies. Crane flies do not like the silt. They will not lay eggs on silty thing. So we have converted, this is a quote from me, a meticulous landscape into a muddiculous landscape. And no one laughed. But it's not funny, right? It's not funny. So, concluded from this is we have a very poor understanding of unintended consequences. A lady from PhD from Purdue. In other words, we do something and something else happens. And when we try to pick out anything by itself, we find it hits to everything else in the universe. John Muir knew this, right? Other examples that could go on and on and on, but that's enough. Of arthropods adversely affected by current management regimes, large beetles like elephant stag beetle I showed you, unicorn beetles live in down, punky, decaying logs, have a 3 to 5 year life cycle. You have a 3 to 5 year burn cycle, they're gone. Luna moths overwinter in cocoons, which fall from the tree and land in the leaf litter. Right? They don't survive with fire. Aquatic organisms that need clear rock bottom streams. They don't have the clear rock bottom streams anymore. One of our scientists, Ed DeWalt, has been studying this in the Shawnee. And anytime there's a disturbance upstream, the aquatic insect fauna declines, et cetera, et cetera, et cetera. So, never leave something but negative. What can we do? Okay, well, simplistically, botanists are going to burn, right? I'll just give it up, they're going to burn. And I've also found out that organisms in the environment, particularly animals, are distributed in 3 different ways: uniformly, very rare, randomly, and clumped random. You know, the little clumps here, a little clump there. This butterflies we talked about, this clump distribution. The crane flies are this random distribution depending on where the dripways were. Okay, all right. So, how do you alter a management scheme to accommodate this? Well, in its simplest form, you don't manage the whole thing, right? We've been harping on this for years. You do not manage the whole thing the same way, but you will impact all those organisms. You can do it this way. You can do it. We just picked thirds because it was an easy number. Sue and I visited Yellowstone National Park after the big fires in 1988. It burned in an incredibly complex mosaic, which means there were places for everything to recolonize from the burned over areas. Another thing I noticed at Illinois Beach is all the cutting, and they piled up their logs in these piles, brush piles, and when a brush pile burns, it sterilizes the soil. The other thing that brush pile does is the brush pile entices birds to sit on it, and birds are crapping out exactly what they fed on, which is more often than not an exotic invasive species. So you're going to cut the vegetation, spread it out, or get it out. Okay. The bird regimes are part of management, and they must consider how organisms are distributed. Not a single person in the Shawnee National Forest had ever heard of the Ozark checker spot. Never heard of it. I said, did you not take entomology in your forestry education? Yeah, we took pest of forest. Yeah, so what, right? Most of those are exotic invasives. They didn't help you. I said, what about forest ecology? Oh, we took forest management. Well, that's agriculture, so that's concerned, right? Anyway. So, given that, a pressing question is, if insects are seemingly plunging into oblivion in protected areas, where on earth could they possibly be safe? Right? So, with that, I take questions. Thanks. And I'm hard of hearing, so Sue will translate for me.
So the flora of the Chicago region now includes bees and the pollinators along with the flora.